Hey guys, it's Miss Markham. I'm going to finish out working some problems with you from our notes the other day. So we're going to work problems 4, 5, and 6 from the ideal gas laws notes that we took the other day. It's in the green packet on the second page. We're going to start with number 4. I'm going to work through this with you, so if you haven't done this problem yet, make sure you write this stuff down. So it says I have a balloon that can hold 100 liters of air. If I blow up this balloon with 3 moles of oxygen gas at a pressure of 1 atmosphere, what is the temperature of the balloon? All right, so let's underline some things here. They give us liters, and we know that liters is volume, so volume equals 100 liters. They also tell us 3 moles. Remember that moles, we use the letter N. That's the variable that we use for moles. And then they also give us pressure, which is 1 atmosphere. So they give us volume, moles, and pressure, and they want temperature. So this is an ideal gas law problem, so we're going to use PV equals nRT. It's an equation at the top of your page there. So we're going to plug our numbers in, but before we do that, we actually need to figure out what our pressure constant is. So remember that we have to figure out what R is. And these are numbers that you don't have to memorize because we're going to give them to you, but there are 3 that we can choose from. And we always use, look at the units for pressure, in this case are atmospheres. So we're going to use the first number that we wrote down, which is 0.0821. So that's our R. Okay, let's plug our numbers into our equation, and then we're going to work the problem in our calculators. So we have 1 atmosphere, that's our pressure. Remember, it's PV equals nRT. So pressure is 1 atmosphere. Volume, they told us, is 100 liters. That equals number of moles, which they gave us 3. And then times the pressure constant, 0.0821, times our temperature, which is what we're solving for, right? So you're going to multiply 3 times 0.0821 in your calculator. You're going to get an answer. 1 times 100 is 100. Whatever answer you got here on the right side, you're going to divide over here. So we would divide to get temperature. Divide by 3 times 0.0821. And the answer to this question is 406. And remember that temperature in these gas law problems is always in Kelvin. So the answer to number 4 is 406 Kelvin. Okay, let's go ahead and move to example 5. Number 5 says, what is the volume of the container of gas if there's 7.7 moles of gas at a pressure of 90 kilopascals at a temperature of 329 Kelvin? Okay, so we have 7.7 moles. So they give us N. They also give us 90 kilopascals, that's pressure. And they give us a temperature, which is 329 Kelvin. Remember, we got to figure out R. We know this is PV equals nRT. Look at your pressure units. The pressure units in this problem are kilopascals. So when you look at your number choices here, you should pick the one that has kilopascals in the unit. And our number that we're going to use for our pressure constant is 8.31 because that matches our pressure units here. And we're going to plug our numbers in. So we have and we're looking for volume, right? So we don't know what volume is. So our pressure is 90. We don't know what our volume is. That's what we're solving for. Let me back up. Okay, well that's a V. There we go. That's supposed to be a V. So we have 90 times the volume equals moles, which is 7.7. Times our pressure constant, we decided we're going to use 8.31. Times our temperature, which is 329 Kelvin. We're going to multiply all of these numbers here, and then we're going to divide by 90. So whatever answer you get here, divide it by 90 so you can get volume all on its own. And when you plug all that into your calculator, you should get 234. And we solve for volume, so we know that our units are liters. So that's the answer to number 4, 234 liters. All right, one more problem here. Let's work number 6. If I have 17 moles of gas at a temperature of 67 degrees Celsius and a volume of 88.89 liters, what is the pressure in atmospheres of the gas? Okay, so they give us temperature. Now remember, temperature has to be in Kelvin, so we're going to need to take 67 and convert it into Kelvin, and the way we do that is we add 273, so 67 plus 273 gives us 340, so that I'm going to write our new temperature over here, 340 Kelvin. That's what we're going to use. They give us moles and temperature, and they also give us volume, which is in liters, and we're looking for pressure in atmospheres. So that's going to help us pick out our pressure constant. If we want our pressure to be in atmospheres, R needs to equal 0.0821. We're going to plug our numbers in here. So we have pressure, we don't know what that is yet, that's what we're looking for. We have volume, which is 88.89. That equals our number of moles, which is 17. Times R, which is 0.0821. Times our temperature, which we calculated at 340 Kelvin. So we multiply 17 times 0.0821 times 340. And then we're going to take that number and divide it by 88.89 to solve for pressure. And you should get 5.34. And we solve for pressure in atmospheres. So 5.34 atmospheres is what you should have gotten on number 6. Okay, I need you guys to continue on. I'm going to make a second video that will talk about combined gas laws that you'll need to take some notes and work some problems on. Okay.